Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Router Bob. We have a great video for you. We're going to make a bean chair on a ShopSabre IS510. I've been wanting to do a video to show you how to go from a product idea that maybe you see somewhere to a production product. Our friends over at Vectric just released a neat plan, and it's called a bean chair, and it's a very unusual product. So we're going to start with their drawing, and then we're going to make the changes we need to turn this into a production product. Before we do that, let's take a look at the CNC router that we're going to be using for this. This machine has a 5x10 table, and I selected that because of the material size that I need to be able to use. It's also a vacuum table, and I need that because I need to be able to use flow-through fixturing to hold those parts of sheet goods. Now, something else I added on here is part locator pins because it makes it easier to load and unload those sheets on the table. Now, something else this machine's going to be used for is not panel processing, so I put the T-slot feature on here to be able to do special setups. This machine has our exclusive Super Z technology. It has an HSD ATC spindle and of course a 10-position tool changer. Since this machine is an IS, it's one of our machine tool grade CNC routers. That means it's precision ball screw drives, that means it's contour guide rails, that means it's an AC closed loop digital servo, and of course our ShopSabre MMP machine control system. If you want more information on the IS CNC routers, you can go to shopsabre.com and watch a special video just on how we build these machines. Now let's go take a look at the software. We found this neat project over on the Vectric website in an area called In the Labs with Becky. Becky takes different projects and shows you how to make them with a CNC router. Let's take a look at this one called the bean chair. All right, here's what the document looks like. And you'll see a picture down here. It looks like it's made out of a Baltic birch plywood. It's held together with bungees. And that's what the frame looks like. And there's some instructions, so it looks pretty nice. And there's the finished product with the cushion on it. So we thought, wow, what a neat project. So what I wanted to do is kind of show you how we go from here to actually making one of those. But something else, one of the limitations Vectric has is they have to output programs for people with a lot of different kinds of machines. So they're very conservative on feed rates and speeds. Well, we don't have that limitation. We're actually going to make this on a machine tool grade CNC router, so because we want to set this up as though I was going to make this on a production basis. Now, let's go to the next step, and now let's look at the actual files that we started with from Vectric. This is a file that we downloaded from the Vectric website. Let's take a look at what's actually included in the file. I went ahead and turned on all the layers up here so you see all the geometry that's on here. And let's take a look at this. Up here, there's actually some drawings with dimensions, and that just shows you how they base this. And some critical dimensions are the material thickness, and therefore the holes that these fit into. Okay, now this area right here, these pieces right here are little keys that get cut out to lock it together. Okay, this is kind of a neat little area down here. This is for testing fits. So these are sample cuts with different settings, and you cut those and then you mechanically just see which one fits right, which one is the correct tightness or looseness. Well, we don't really need that because I have a digital caliper, so we'll trust that. You'll see some holes on here. Some of those holes are to actually screw the piece down. Some of them are for alignment when it's flipped, which brings up an interesting issue, and is why is there machining on both sides? If you look over here, you'll see it's showing two-sided machining. Okay, well, let's figure out what's going on there. We machine on two sides because there's something that we can't reach from the other side. Well, let's see what that is and make a determination of how critical that's going to be. So let's go up here and let's look at the other side. We flip it over, and it looks like, other than some holes for pins, which we're not going to need because we have a vacuum pump and a vacuum table, looks like there's really two things. There are these pieces of geometry here, and I call these spokes, and for no other reason. Those actually can be machined from the other side, so we don't have to flip it to do that. The only other thing that's left are these little marks here, and what they're planning on doing is actually taking a ball nose tool and machining those, and they're doing them on both sides. But you got to really question, they're not really required, and I think about why. On the outside where you see it, there's a little track that the bungee cord runs around, okay, that it runs in. Then on the other side, this rope is just going across there. So what I'm really interested in more than anything else is to make sure I don't have sharp corners on the insides of those holes. Well, we can handle that pretty easily. In woodworking, there's a concept called softening the arises, all right? Well, an aris is a corner, so it means rounding off the corners is what it really means, and that's normally done in a finish sanding process, so that when we do all our finish sanding, we knock those sharp corners off. Now, that's done for a couple reasons. The main reason is because of finishing. If I use a finish with a top coat, that what happens is the surface tension on the finish tends to make it draw away from the edges on those sharp corners. So you end up with a corner that doesn't have much finish on it. The consequence is it's real easy to rub that finish through. So the way they get around it is they sand a small radius on there that causes that liquid finish to wrap it around and give you a consistent thickness. Well, we're going to do the same thing when we do our sanding, but what that's going to do is knock the sharp corners off that could damage the cable. So because we're doing that, that pretty much eliminates any need for backside machining. So now we can actually go through this and figure out exactly what we need from the geometry and then how we're going to tool path it. Okay, now let's take a look at the geometry that I'm actually going to use for this project from the master drawing. And one of the things, of course, I changed the orientation so that the X and Y axis are correct. And the first thing I did was went over to the material definition and made sure that this fit my material. It's a little bit thinner. Okay, that's okay. And then let's look at what I actually kept, okay? For one thing, I took these keys and I turned them 90 degrees so the grain direction will be running with them. Let's see what else we kept. I had to make some other changes based on material thickness, and these little slots right here had to be redrawn, so I redrew those. Same thing here. And then these had to be moved slightly over. If you look at their master drawing, they dimension how far it is from here to the inside of that, and it's material thickness, so I made those changes. Pretty much everything else stays the same on here. Okay, so that's what I did, and then I saved that drawing. Then our next operation is figuring, okay, well, now that we have our drawing and everything's laid out and we have what we need, everything's on one side, how do we approach actually machining this on our machine? So let's do that next. Now we're ready to get down to the nitty-gritty. How do you actually approach tool pathing this? So let's talk about that a little bit. First off, we've got a machine tool grade router, so the tool or horsepower is going to limit how fast we cut, so we don't have to worry about all that. All right, we're going to use flow through because I don't want to tape anything. There's a couple little pieces I will have to tab because they're so small, but nothing else will have to be tabbed. And so then we start thinking, well, what am I going to do first? Well, I typically tool path in the order that I want to cut on the machine. You can change that later, but probably the first thing I'm going to do is cut these little pieces down here. They're keys or pegs or whatever you want to call it. And I actually attach it together, and I have to worry about those moving because they're small. So I'm actually going to tab those. I'm going to leave a couple little tabs on each one of those so that when I'm finished cutting, they're pretty much in place. Now, I'm going to use a downshear tool for those, and I'm going to take more steps than necessary because I don't want to take a chance of those moving. So the first thing I'm going to do is actually go in and cut those out, and this is what that tool path looks like. And if we look at it in simulation, we get over here, we can see it a little bit. There's the tool paths, and then if we go simulate, that's what's going to happen. So the first thing that's going to happen on our sheet is we're going to cut those out, and you see the little tabs there. So that's going to keep them in place. That's going to keep them from moving. And like I said, I did more passes because I didn't want to take a chance of those moving. So that's our first operation. So the first thing we're doing on here is cutting those pegs, or what I call keys, out. Now let's look at the next tool that we're going to use. The next step is to actually tool path some of the internal stuff. So, you know, we've got some little pockets here that need to be cut out. We've got some right here, and then we've got some holes that need to be machined. Let's take a look at this one. All right, that's this one right here. Let's open that up. Now, what those are actually just rectangles with dog bone corners. And so they're drawn the correct size, and I've selected the tool and I'm cutting through. But here's one of the things that I want to account for, where it says pocket allowance. I want some slop in there so that I can put it together. If you have it the perfect size, you won't be able to get it together. You have to drive it in. Well, the question becomes, well, how much play do you need? Well, think about that. If I take off 5 thousandths on both sides, that's a total of 10 thousandths. That'll be pretty good. And so that's where I'm actually adjusting for that. And if it were wrong or I need to tighten it or loosen it, all I have to do is change that number. I'm doing the same thing. We'll close this. I'm doing the same thing over here on the keyhole. Same idea. All right. So there's that. All right, so we got that done. Now let's look at these holes, the actual holes, because I've done them a little differently. And what's happened to the profile holes? Let's open those up. What I've actually done here is I've actually taken a 1/4" bit. I'm cutting on the inside, but watch the ramp. I'm doing a ramp and I'm actually doing a spiral. Now here, I'll show you up close why that works so well. Let's look at that in 3D. We'll turn that on and we'll get that actual hole. Whoops, let's get the profile holes. Let's see if I can get in there and you can see those. What happens is, there, look, the bit comes up here and then it goes in a spiral circle all the way down to the bottom of the hole. So it's a really, really clean move and it gives you a real accurate cut hole and it doesn't burn with the router bit. So that's why I've done that. So that's a real good setup also. Okay, and so basically we've got this done. So if I go hit these, we'll just go over here, we'll turn that off. So now we'll simulate that one and we'll see that. There's our holes, and then here's our little tenon holes, and then here's our keyholes. Right? So that's what we've done to start with the 1/4" compression bit. Now the next thing we need to do is the area that I call spokes, and we need to talk about that a little bit, how we're actually going to accomplish it. Now I want to take a look at this area called spokes. Before we do that, I've got the toolpath we've already looked at checked. If I click this, it's a lot cleaner. It just shows in solid where the cuts are, so we can kind of keep an idea of what we've got done. All right, well here's what I've got to do at this point, and that is I've got to cut these little shapes out so that what I have left are the spokes. Well, I don't want to use tape and I don't want to tab all that stuff, so I've got to figure out how to do this with vacuum. Well, obviously, when you have the really, really small ones, they're probably going to fly out. So we'll just turn those into chips. So that's what those are. So in those areas that I say, okay, these are probably small, we'll just turn them into chips so there's nothing to fly out. So we're going to do that first, okay? Then the larger ones that are left, we're going to cut each one of them really the same way. We're going to use a 1/4" bit. We're pretty much, our start point's going to be on the middle of a long edge. We're going to ramp in. We're going to go all the way around, and this is plywood, so we're going to be conventional cut. It'll cut better if you on plywood. We're going to cut each one of these and leave about 30 thousandths, then go through and cut it the rest of the way. And the reason we're doing that, that's an onion skin process, so that holds it in place. Then we go back in and just cut through that onion skin, and the cutting pressure is so light it doesn't make the part move. So if everything works right, those pieces should all lay there. All right, and so hopefully when we get that done, that's what it's going to look like. Let's go back to simulation. Let's clear all this out. Let's reset our simulation. There's all our toolpaths. So let's preview all visible toolpaths. So at this point, this is where we're at. Okay, so that's looking pretty good. If I double click those, you see, those will come out. So that's kind of neat. So that gives us the effect. And if everything works, vacuum's going to hold that scrap piece in the middle. Okay, now before we cut the outside parts, let's stop. We've got one more operation, and we need to take a ball nose tool and we need to cut those little bitty slots for the rope. Let's do that now. Okay, now before we can actually go to the steps where we actually cut the pieces out, we've got one more operation to do. And that's these little lines here that get cut with a ball nose tool, and it forms a little track for the rope. And let's go ahead and turn on all the other tool paths that we've done so far. So let's get those on where we know what we're doing. Okay, and there they are. All right, now, so what we're going to do is we're actually going to hit these lines right here. That's what they look like. That's what those are. And now let's go back and do our simulation, and we'll take a look at it. All that's checked. We'll reset. Now we'll preview visible tool lines. Okay, so now, so far the tool pathing that we've done creates that part. We've got two more things to do. We actually need to cut out the rails, and we're going to treat that separately, and then we're going to cut out the actual end panel. So let's take a look at those operations. All of our non-through machining is completed, and now we're ready to start cutting our parts out. And the first group of parts that we're going to cut out are the cross braces. All right, now those are actually fairly large parts. We're going to actually cut them with a 3/8 bit in a single pass. And one of the ways we do that is, let's open that up a little bit. First off, what we're going to actually do, if I open that, the midpoints are going to be in the center. So I'm going to start in the center of a long edge. We're, of course, be conventional cutting because that's plywood. We're actually going to ramp in, go all the way around the cut, overlap slightly, and ramp back out. And we're going to do that in a single pass in all those. We really don't need to do any kind of onion skinning or anything like that. So that's that part. All right, let's take a look at that in simulation. And so when we simulate that part, that gets those cut out. And then the last thing we need to do are actually cut the final large outline parts out. Okay, we have one more tool path and then we'll be finished, and that's to actually cut the outsides of these two end panels. We'll use the same type machining that we did earlier. And let's check this out in simulation. So we'll look at that in 3D, we'll clear all those, and we'll just say preview all tool paths, and that's what's going to happen on the machine. All right, so when all the tool paths are done, get rid of some of those if we want, we should have everything ready to actually make the bead chair. Now, let's send these files out the machine and let's go cut this out and see how it comes out. Well, our bean chair came out really, really good. You know, the edge finishes are magnificent and the accuracy is so good. You know, what I wanted to do with this video was show you how to approach something. You see a neat wood product and you say, well, how could I get into production on that? That's how we approach this. And I hope you enjoyed this video. If you have any questions, you can contact us at ShopSabre.com. Thank you for watching.